Radical dude, yeah. And today we're going to talk about properties of exponents. Properties of exponents. And the exponents are a power. So for example, you sometimes see x cubed times x squared, right? You have your bases and you have your exponents. And some kids go, oh my gosh, what do? Am I adding these to make it 5? Or am I multiplying these to make it 6? So you have to think about, well, what does x cubed mean? X cubed means x times x times x. That's x cubed. And x squared is x times x. So how many x's do you have? You have 5. You have 5. So, to come up with the formula, they just say x to the a times x to the b is equal to x to them, and you take these and you add them. Nice and simple. That one's done. Let's do another property. How about x to the 6 over x squared? Now we're doing division. Okay? Some people go, wow, what is this? Do I subtract these and make it x to the 4? Or am I dividing and making it x to the 3? Because 2 goes into 6 3 times. Well, what is x to the 6? X to the 6 is x times x times x times x times x times x. There's 6 of them. And what is x squared? X times x. Well, look what happens. These cancel and these cancel. And what am I left with? X to the 4th. So here's another rule we can use. X to the a over x to the b equals x to the a minus b. Ta-da! Nice and simple. Now, sometimes you get a power to the 0 and it equals 1. And everybody knows any number to the 0 is 1. But why is that? Well, let's see. X to the 0. Well, what could get me 0 is if I take any number and subtract it by itself. So I'll call this a. A minus a. So this is x to the a minus a, which is 0. Now from our last rule right there, I can write it like this. Right? Because the quotient rule of exponents shows that when I divide, I'm really subtracting the exponents. But isn't it true that any number over itself is 1, right? When you're a little kid, you say, what's 5 over 5? You say, 1 whole. Well, there it is. 1. Therefore, x to the 0 is 1. What's another one? How about negative? This x to the negative a is defined by 1 over x to the a when you have a negative exponent. And let's see why that is. Well, if I were to give you x to the minus 3, just say, okay? Well, let me try to get two numbers where I can have a difference of 3. So I know 1 minus 4 is negative 3, right? So that means this is x to the first power over x times x times x times x. It's 4 against 1. Right? These all have hidden 1s on them, so you don't even need the 1. Now they fight. These cancel, and what am I left with? Well, if you're left with nothing up here, you have to put a 1, because x over x is 1 whole anyway. So this is a 1. And what about the remainder is 3. So it's x to the third. Therefore, x to the negative is 1 over x to the positive, the x. Okay? The other one I wanted to show you was with the square root. So let's look at this. Why is the square root of x equal to a half? Where did they come up with that? Well, they said square root of x times square root of x, right? These radicals cancel and you're left with x, right? We're talking square root of 5 times square root of 5, that's square root of 25, which is 5. So you just take out the radical. Well, we want to know what this exponent is, so let's call it a. X to the a times x to the a. Well, what is x to the a times x to the a? We're supposed to do what when we multiply? We add the exponent. So a plus a is x to the 2a. And x to the 2a, we said was equal to x, right? And this is to the first power. So therefore, 2a equals 1. Divide both sides by 2. And you get a is a half. Therefore, this is a half. See? That's that. And the last one, not to get confused, what happens if I have this? Is that x to the 5th, x to the 6th, 4x? What is that? Well, first of all, x to the cube, if you visualize a cube, it looks like that. And if you visualize a square, it looks like that. So if I have a box and a sheet of paper, then I have one box and one sheet of paper. I don't have 2 box sheets of paper. So therefore, this is just x cubed plus x squared. Well, this has been Radical Dude, and I hope you learned something.